So this is the item results. Have you ever had a teacher that goes over this after a Moodle test? Okay, so we do this after every test, although we're not going over everything, because he's going to retake the test, and if I go over everything and give him all the answers, then that won't be fair, will it? So this one was only 50% answered correctly. Why was it only 50% answered correctly? Because I didn't go over this, and I should have. So there was, I thought I took it out.
Who got it right?
So, huh?
Who got it right?
I don't know. Half you got it right, half you did not. So there, when I was making the test, I found some things that I had forgotten to go over. That I'm like, okay, I got to go back. I got to go over those things. That way, I took out all the other questions, but when I was making the test, I was like, oh, it's too late to go over it now because I already said the test is Tuesday. So there's some additional stuff that I need to make sure you guys know for the class. Okay, to understand things. Okay. So, first definition that you should remember from Computer 1. What is a bit?
A piece of data? I don't know.
Okay, that's good. It's a piece of data. It's one singular piece of data. And what are the two ways that data can be represented?
Bits and bytes?
No. We're still on bits. Bytes is something else. Okay, so what are the two things that could be in that bit location? What? No, there's only two things.
1 or a 0.
A 1 and a 0. It's either off or it's on. Okay, that's the only thing that's held in a bit. And that off and on, 0 is off, 1 is on. That's the electrical impulse that's being stored inside that singular bit. Okay, which is also why on the back of computers, the on-off switch usually has a 0 and a 1. Why? Because some computer guy was going, I wonder if they'll know what this means. Because people go and hit the 0 because that means on, right? And it won't be off. Okay, so it's either off or it's on. Okay, it's the only thing a bit holds.
Pardon the interruption. At this time, all juniors should report to the middle school cafeteria for the pictures. All juniors to the middle school cafeteria for pictures at this time.
That's why you look so nice today. His
I
camera combed and everything today.
I did
He's
not.
like, I'm looking fine for my pictures. I, on the other hand, keep walking in. I'm like, what?
Pioneer?
I'm recording. Yes, we're talking about stuff. What can I do for you before I can proceed on with my lesson?
I tried to Google why my machines are shutting down on Windows.
A bit is then a singular data item. It's either a 0 or 1. Okay? A byte, and a byte is what?
8 bits.
8 bits, okay? So a byte is 8 bits. We have to get the original, the first, groundwork here to make sure you guys remember that. Okay? Now, we talk about bytes a lot of times, but sometimes we talk about bits. Okay, so when do we talk about bytes? We talk about bytes really when we're talking about storage. We don't talk about storage in bits. So when we're talking about a hard drive size or memory, and this is why I should have talked about it because it really hits a whole bunch of. So when we're talking about those storage sizes, we're talking about them in bytes. Okay? And then we have to go on to the metric system as it relates to storage, because we're going to use this. These were test questions that I didn't give you, okay, because I knew that you didn't know it, okay? So if the byte is our base that we're talking about, just like when you're over in your chemistry class, the liter maybe is the base that you're talking about, okay? What is 1,000 bytes?
Megabyte.
Mega?
What?
Giga?
Wait, one of you said it. That's name one metric term, not all the ones that we know, and hope that rapid fire we got one of them. Okay. So my first question is, what is 1,000 bytes? And the answer is
Kilobyte.
kilobyte. Okay. So kilo is the term referencing 1,000. So if we had 1 KB is 1 kilobyte, okay? So that's one of the ways we talk, that's the first metric term that we talk about. all the decas and those other ones we don't talk about, we go straight to 1,000. Okay, and the next one we go to is 1 million bytes. Come on. Okay. So 1 million bytes would be a megabyte. Okay. So a million is a mega. Okay, and that would be referenced as MB. Okay. So a megabyte is a million bytes, and it's referenced as MB. Okay. Then we've got a billion bytes. And what would that be? Giga. Okay. Okay, now some of these we're not going to be talking about memory anymore. Okay, this is where memory right now starts. Okay, stops. I'm sorry. So you can have gigabytes of memory. Okay, but we don't have any higher increments of memory than a gig. Okay, this PC holds 16 gig max. Okay, it's a server. It's really sweet. I got to show you the inside of this bad boy if I can open it up. Which side does it open? This should be from this side. I just have no idea. Oh, there we go. So this one has not one, but 2 CPUs on this motherboard, and it has not 1, but 8 memory slots on that motherboard. Just got that for free from the Air Force. Okay, so this is a really decent. I'm sure they spent thousands of dollars on that server right there. It's probably not worth that much anymore, but it's still going to be a real decent machine. But even the best machines, we're talking in gigabytes of memory. Okay, but there is another term that we use, and that's 1 trillion, and that's a trillion, and that's a terabyte or a TB. Okay, that's as big as we've gotten right now when we talk about storage, and that's only used right now when we talk about hard drives. Okay, so, and that really only happened in the last 2 years that we got hard drives there in the terabyte ranges, but when we did, we moved pretty quick. This hard drive right here, it's 3,000 gigabytes of storage, which is 3 terabytes. They don't write terabyte on there. Why don't they write terabyte? Because a lot of people have no idea what a terabyte is. So why put something they don't understand? We'll put 3,000 gigabytes, because they knew what a gigabyte was when I sold them a 500 gigabyte drive, so they'll know what a gigabyte is when I tell them a 3,000 gigabyte drive. That's why it doesn't say terabyte, but that's what it is, okay? So if I said it had 1,500 gigabytes of storage equals how many terabytes, you would say?
1.5.
1.5, okay? And the test should have had questions like that on it, because you should be able to transfer back and forth, and there's a reason for that, and we'll get to that in the motherboard section. Okay, so that's our metric system as it relates to storage. We also have a metric system as it relates to speed of components. The speed of things in electronics is related to the cycles per second. Okay? A hertz equals 1 cycle per second. That means from this spot to this spot is 1 complete cycle, okay, in electronics. And that's what a hertz is. A hertz is 1 cycle per second. And so we rated in how many of those happen in a second, okay? So hertz means 1, so if it was moving at 3 hertz, means that there were 3 of those cycles per second, okay? So that's like bytes are the rating for storage, hertz is the rating for speed. So particularly when we talk about CPUs, motherboards, memory, graphics processors, and there's more. we usually talk about them in some relational speed in hertz, okay? Because that's how we compare things, okay? And so when we're talking about those, we're talking about them in hertz, and we look at the same thing, okay? So if a hertz is 1 cycle per second, okay, a kilohertz is 1,000 cycles per second. A megahertz is 1,000,000. A gigahertz is 1,000,000,000. We don't talk in terahertzes. Nothing goes that fast. Okay, we're still in single digits of gigahertzes when it comes to speed. Okay, so when we're talking about a CPU, we may say that CPU is rated at 3.2 gigahertz. Okay, that's the speed and that's why I'm saying we're still in single digits of gigahertz. That's why there's no terahertz now. Yeah, okay, although the term exists, but we will never use it because nothing actually works at that speed. Okay, so CPUs we might say work at 3.2 gigahertz. We might say a motherboard works at 800 megahertz. It's very normal. Okay, and we'll talk later about what's called the bottleneck. This is the motherboard bottleneck because this would be a normal PC. That this is going how much faster than this? Quick math term. I gave it in a multiple. How many much faster?
2,200.
How much faster? How much faster? How much faster? How much faster? Right, 4 times. It's going 4 times faster because 8 times 4 is 32, and 32 million would equal to 3.2. Okay, you got it. Okay, so you see what I'm saying? That's why we have to be able to transfer these numbers, because really this is 3,200 megahertz. So if I'd written like this, maybe it'd make more. And this is going at 800 megahertz, because that's the same number, right? Same number. How much faster is this than this? Oh, that's just 4 times that. See, now the number makes sense, because you were like trying to transfer things that didn't transfer, okay? So that's still 4 times faster. So when I ask questions like that, put them in the same terms. Okay, I could have said 3.2 and 0.8. Points make students confused, right? So it's easier to do this. But if I said how many times faster, that means how many times of one equals the other. That's what that term means. This is 4 times faster than that. And that's normal. That a CPU is 4 times faster than the motherboard. And the CPU is going this much faster than this. The motherboard is the bottleneck. CPU is going on. I was finished with that 5 minutes ago. Get it out to the graphics card, okay? Because it's done. Because it's 4 times faster. And this is a normal occurrence.
Pardon me, teachers, for direction at this time. I need all sophomores A through F. A through F down to the cafeteria to have the elementary.
So both of you?
To have your
No.
pictures.
H.
Thank you.
No.
W.
W, right. So we got to reprieve. We're going to finish this. All right. So really those are the 2 things. With this term is used to talk about speed. CPU speed, motherboard speed, memory speed, graphics processor speed. The speed of this memory right here is 400 megahertz. Okay? Speed of that memory is 400 megahertz. I guarantee you that there will be CPUs that will be able to fit in the same motherboard as this memory that go 3.2 gigahertz. How much faster is it? If 8 times 4 is 32, then 4 times 8 is 32. See, it's saying 8 times faster. The CPU is 8 times faster than the stick of RAM. In this case, what's primary storage? This slow piece of crappy RAM. The CPU is going, come on! I wrote that to you 5 minutes ago. Give me my data back, right? So these things are all the same relation, but this one's way faster than these other guys, okay? And these other guys slow him down. So if you go and put the fastest processor in the world in your motherboard, and you have a really crappy motherboard in relation to that processor, you don't have that fast of a PC. Because this guy is still going to be waiting for this guy and this guy. And if you have a really good motherboard, and you put a crappy piece of RAM in it, the motherboard slows down to the speed of the RAM because they sync. That's why this is called synchronous RAM. It synchronizes with the motherboard. So then you just took this really good motherboard and this really good CPU and you chinched out on the stick of memory by $8 and you slowed it all down. Okay? So all these things sync up together, by the way. They always go the same speed of the slowest. And then the CPU puts up with whatever speed the motherboard gives it. So we have to have some way to relate those numbers, and that's what Hertz is. And we're going to talk about some other times we talk about Hertz when we talk about alternating current as well, but we're not going to get into the electronics or the electrics part of it today. Okay, so that's something I forgot to talk about. And I was like, oh, poop. I never even mentioned that. And half the people guessed right, half the people guessed wrong on the answer, right? So everybody will get credit for it right. So if you got it wrong, you'll get credit for it right. If you got it right, you won't be. I was going to just delete the question, which is the easiest thing for me. But if I delete the question and he got it right, then I just lowered his test grade. That doesn't seem fair. Because I made a mistake, right? So I'm just going to have to go through, find the question for everybody, and override the answer and give them credit for it. Okay, let me think. Is there anything else I forgot to go over in chapter 1 that I wanted to when I was going through the test questions? I don't think so. I think that's it. We have we're not really done with chapter 1 because I missed one item, but you know what? I'm just going to skip that and we'll do that in chapter 2 because it's related to chapter 2. Chapter 2 is about software. And really, that's the only time we're going to talk about specifically about operating systems a little bit more than we have. And it's when we're going to talk a little bit more about drivers than we will. Although drivers will relate to all the hardware as we go through the course. Chapter 2 is specifically about software, and we're going to load some drivers, and we're going to load some different operating systems too as we do chapter 2. And we're going to start chapter 2 next class. Possibly it'll wait until Tuesday, okay? Because right now I'm going to say we're done with today because you guys are going to get pictures done and we've got some labor to do. So I'm going to go ahead and stop today because I got to